Come on in. Okay, and so I was just introducing myself. I'm Ms. Thomas, and so I teach ACT. I do private tutoring for classes. I actually teach Algebra 2 as well for a large homeschool co-op. So I'm kind of in the throes of it all the time, of math and what it needs to be. So what is the ACT and why are you here? Who all has taken the ACT already? Everyone already taken it. Okay, great. And it was the easiest test you ever took, right? No, not so much. Not so much in that. Okay, so why is the ACT different than the SAT? We hear a lot about that with it. Well, number one, SAT kind of focuses on applications of a lot of learning. ACT is what do you know? Which is great for us because that means that if we can learn some new stuff, then we're going to do a lot better on the test, right? Another thing for the ACT that I'm intentionally going to try to show you guys is how the problems build upon each other and how the concepts build. And so things that might look really difficult, or you get to the end of the test and it's in those 50s, the 40s and the 50s, and you're like, I can't do any problems that are in the 40s and the 50s. Those are the hardest ones on the test. Of how actually it's actually the same concept that we've had before, and you can have the confidence to go, oh, it's just the same thing that I did on number one. It just has variables now instead of numbers. And so we can grow that confidence of saying, it's stuff that I've already learned. We're just gonna learn it a little bit differently, okay? So for this class specifically, this is the, we're gonna boost your score that you already have. We're not working on the nitpicky. We're kind of looking on the big picture of stuff. We're gonna specifically talk about some common mistakes that make. I'm gonna tell you the things that you absolutely 100% need to know, and we're gonna do practices over those. And are there gonna be other concepts that are sprinkled throughout? Yes. There are 87 separate concepts that they can test you on for the ACT. Can we learn all 87 of them? No. Not in 3 weeks. We can't, but we can learn the big groups for that, okay? So we're gonna work through that. And this is just me reminding you, no, I can't teach you everything, but we're gonna learn a lot, so take a lot of notes. I've got a lot of notes through it. These are a specific list of what I consider basic math items. And then just so you guys know, these slides are a part of my Google Classroom. So because you are taking this session, you will have access to my Google Classroom. It's a private one until you take the test. And it has lots of practice on it. It has all these slides. It has Google Forms that you can practice as many times as you want. It has 3 completely worked out tests on it. So those are resources that you can use at home if you want to. But if you see functions, you need to know what this means. And to be able to plug in, if it says f of 2, that means I put 2 in every spot of x for it. So knowing how to do functions, knowing how to solve them and plug them in. Combining like terms. If we have 2x plus 3x, we need to know that that's 5x for it. So those are basic things for that. This looks a little different. Probably you're used to seeing PEMDAS, right? So I will quickly go over that. Everything in math is very orderly. It has a pair that does and undoes each other. And when we understand that concept, that we've got these pairs that do and undo each other, it helps your brain figure out those parts where you're like, I don't understand maybe what to do on that part. Oh, but I know that this is a pair. So addition and subtraction, we know that one, right? Multiplication and division is a pair. Exponents and roots. Exponents and roots are a pair. And so all of the rules that apply to exponents mean that they're the exact same rules that apply to roots. And that's why it's important to understand that it's a pair. It's not something completely different. It's just, oh, we can use our exponent rules for it. And then, of course, our parentheses. So rearranging any equation, you need to be comfortable rearranging equations. Rearrange 2x plus 3y equals 6. Rearrange it for y, or solve for y. Time. There is always at least one problem on the test that has to do with time. Again, is it worth it for that one? But if you know how to do it, then that's a point that you can get, or 2 points, that you can get easily. So difference in time, he left San Francisco at one time, and he landed in New York at another time, and there's a 3-hour difference. Understanding how to change AM to PM, 8 o'clock to 11 o'clock, those type of things, and the difference between it. Systems of equations, solving systems of equations. This is a note, extra note for you. They will often have systems of inequalities. So far on the last 10 tests, there has been one of these every single time. So systems of inequalities look like a y is less than or equal to like 3x plus 8, and then they might say 3x plus 2y is less than 4, or something like that, okay? So they're gonna give you 2, and then they're gonna ask you about the greatest value, or what's the absolute value of the solution, or they're gonna imply something else. Every single one of these has been the solution at the point where it meets. So if they, or a lot of times they will just say, or x is less than 2. In it, my suggestion is whatever they tell you it is, consider that an equal to sign and just plug that back into your other one. And that will be your answer every single time. It has been very consistently for them. So when you see a system of inequality, like know how to work your systems of equations. But for systems of inequalities, I'm like, if they give you x is less than 2, consider this x is equal to 2, and plug it back in the other one just like it's a function. And I guarantee you, you will have that answer correct for that one, okay? We are going to discuss a lot of fractions tonight. So knowing that we have to have a common denominator is very important for fractions. And then how to cross multiply. Meaning if I have 2 fractions that are equal to each other, so I have 1/2 and x over 3, how do I solve this? We cross multiply. 3 times 1 is 3. In this case, and then we've got 2x, and then we would divide back, so x equals 3/2. So cross multiplying or finding a common multiple that we're going back and forth. So we'll do a lot. We will do more practice for that, but we need to understand the concept of cross multiplication and then review scientific notation. Just know which direction those decimal points head for it. Again, these are ones that are kind of one-offs, but they're very consistent on it. So if we have extra time on our 3rd session, we'll review some more like this, okay? So with all of this and with the ACT, it's going to ask you to find an answer, because that's the whole purpose of algebra. We're just trying to find an answer. So make sure that what you're answering is what they've asked for. That's where we need to be consistent. A lot of times we find an answer and it's not what they asked for. And the thing is, for ACT, we have 60 minutes for 60 questions. Are they gonna give you super complicated questions? No, really they're not. Because if we break it down, it's a minute a question that we have. And they know that, and so they're having to work within the constraints of 1 minute a question. And so it's important that we circle, we highlight, we try to find out what they're asking for, and then use what we already know for. So tonight we're going to cover a lot of the algebra of the ACT. Next week is going to be all geometry and graphs. And then last week we're going to cover probability and statistics. So on a test, everyone has a copy of this either in their folder or one that I've given you. This is a worked out ACT test, okay? It is color coded. Why do I color code it? Because I think sometimes it's important to have a visual for what they're giving you. It makes it not so stressful, okay? So if you start flipping through it, you might start seeing patterns on your own and go, oh, it has a lot of the same color dots in a row, one after another, right? Well, whenever we do that, what that does is psychologically, if we walk into this test and we go, I know that it is very, very common for them to do same concepts back to back, that if you get in a place where you have to skip a question and then you have to skip a second question, Mentally, that can really shake you when you're under pressure, especially this is second test, you've already finished an English test, right? But if you know, oh, it may not be that I feel really inadequate being able to know my math, it may just be that it was two of the exact same concepts and I need to just skip to get a different concept for it. It helps us mentally be able to take that breath after we've skipped a second one, okay? At the top, it shows the 5 categories that the ACT tests you on. And then I've got this purple category because the ACT, when they send you back your report, they call this IES. This is your integrated systems. So what does that mean? It means they've just taken that concept and they've put it in a word problem. Or they've asked you to find it through a different way. So these are our basic ones that they consider. These are the others. The breakdown, the actual numerical breakdown has been the exact same for the last 8 tests that I've done. And so number and quantity, there will always be 9 of those, or there has been. There's always 17 algebra related problems. There's always 11 function related problems. So that may be a graph or finding a point on a function or things. There's always 15 geometry questions and then 8 probability and statistics questions. So we're gonna address the major algebra ones that we have. We're spending an entire night on geometry because if you notice, it is 1/4 of the test. And geometry really isn't that hard. There's only about 3 formulas you need to know and everything else we can tie on top of that. And we are gonna spend some time on probability and statistics, and you might say, Ms. Thomas, why? Because there's only 8 of those. Because they're very easy. Probability and statistics questions are typically very, very easy and can be solved very, very fast. And so these are easy points for you. I want to get you the easiest, fastest points that we can get. And then with extra time on top of that, we will go. Okay, so for tonight, we're gonna go over exponents, fractions, lots of fractions. Fractions are actually found in all 5 areas of this test. Absolute value, there's consistently been 3 to 4 absolute values on the test. Slope in all forms, and then some word problems. So that's what we're going to be discussing tonight. We've talked about this already, so we already talked about our steps that pair up to undo each other. If we know the pairs, again, it helps us work back and forth. Another pair that's very important is multiplication is often paired with addition, and division is paired with subtraction. So that's just another one that we can tuck away in our head and go, oh, for exponents, let's talk about a basic exponent. X squared times x cubed, okay? When the bases are the same, we add the exponents. Everyone agree with me here on the exponent ones? So I'm multiplying, yet I'm adding. Well, what ends up happening is since logarithms are the opposite of exponents, if I have log of x times y, I can say, even if I've never seen this, and they give me a whole bunch of examples, I can go, oh, well, I've got an exponent, I have a multiplication, I know multiplication and addition are a pair, and so they're probably only gonna have one on there that has addition between them, and we go, oh, I've got multiplication, addition as a pair. It helps us be better guessers when we understand those systems and the processes for it, right? So multiplication and addition, and start noticing those patterns, and division and subtraction. We will look at those. Okay. This word, I think, rational numbers, ratios, a lot of the ACT is they are asking you, or they use vocabulary that you say, I don't know how to answer that question because I don't know what those words mean. Because they've used some random word on there and you're like, I don't know what that word is. So a lot of it is just knowing, they're like, what rational number is, whatever. You're like, I don't know, what's that? So remember that rational is not something confusing. Rational has the word ratio in it. It just means any number that can be written as a fraction. So rational simply means a fraction. Every time you see that, ratio means a fraction. So when we see these terms, just write a fraction bar automatically. Go, I know that I'm going to have to put a fraction down for that. And that will help, that kind of helps our brain pick up on what to do, okay? Fractions are found all over the place. Fractions are in probability. Every part of probability is a fraction. Every part of comparing similar figures for geometry is a fraction. Every part, like even rational, they'll say rational exponents, it just means a fraction as an exponent. Okay, same thing. And all fractions are how much you have over how much you need, right? I have half the pizza. So I have one piece, I need two pieces to make a whole one. So they're always going to be in this form, have over need, no matter where we find them, right? So these are all of the areas on the SAT, or the ACT that use a fraction, okay? So we've got rational equations, just means two equations with variables that are set up as a fraction. Rational exponents, square root of 4 can be written as 4 to the 1/2. It's got a fraction. Probability is a fraction. Word problem comparisons are fractions. Fractional, just a basic fractional equation, we've got geometry and trig, so area, scaling, comparison for like sides. Statistics, all of those are fractions or percentages. And then unit conversions, miles per hour. That's actually miles per hour. It's just a fraction. Anytime that we are doing unit conversions or comparisons in that way, they're all fractions, all right? So we've got to be very, very comfortable with fractions as we work through, okay? So I have lots of fraction resources on my Google Classroom, and we're gonna work through those today. So here's some examples. Comparison of like shapes with a fraction. This is a test question. It said in the figure below, E and G lie on ACD. And so we basically, here's the thing. When they give you a picture, the ACT will tell you the pictures aren't necessarily drawn to scale and whatever. That's not true. They are always drawn to scale. They are always accurate. You can very much use your pencil to measure it often. Like use the picture that they have on there, okay? And then they give you a whole bunch of information that tells you what you see is actually what you see, right? So don't get lost in all of the information. Let's just head directly, let's find what they're really looking for, okay? So it says, what is the length of AC? So right away, I'm going to find AC, and I'm going to put a question mark on it. I'm going to go, I need that guy. So how can we compare that guy? Well, he is the long side of this large triangle, correct? Let me see if that's on the answer. Okay. So he's the long side of this big triangle, and I need to compare it to something else. Well, do I have another triangle in here that I can compare him to? Yes. I've got this short little triangle that I can compare to. So if we separated them out, we would have a short triangle that has 8 and 16, and we have a large triangle that has what I want, and I have to find the comparison side for 8. Where is that? It's all of these values right here. Okay, so we would need to do what with 8, 7, and 6? Add them up. We would need to add them up and go, I've got 15 plus 6, so I've got 21 on that side. And so now we can set up a ratio. We can either say 8 is to 16 as 21 is to x. So we can write it like that. As long as they're the same, short to long, short to long. We could do short to short equals long to long. Same way, but they have to be in the same order, right? If we go 8 to 16, we notice that that's actually 1/2, right? And so we need double of 21, which is going to give us 42 on that guy. Any questions about this one? Okay, so there's a comparison. We can have a comparison with like volumes. This guy's having a hard time. Okay, with volumes, there's two different ways. We can solve with our volume equation, okay? And know that volume equation is length times width times height. That's a formula you need to have memorized. And actually work out the volume of the first one and the volume of the second one and figure out what it looks like. So the volume of this one, we've got 1 times 1 times 1 gives us 1. We'll call it cubic centimeters. And then I've got 2 times 2 times 3 gives us 4 times 3, 12 cubic centimeters. So the ratio from the first one to the second one is 1 to 12. The volume of the large prism is the same as how many small prisms? 12. Okay? Now, if you get on the test, you're like, I don't even remember what volume looks like, and you have a brain freeze, how can we logically work through that? We could say that, oh, I have 1x here. How many x's could I fit on this side? I would have 2 of them, right? So this guy is half of this one. I've got 2 here. I've got half of that, and I could fit 3 of them, so I've got 1/3. So if I've got length times width times height, I've got a ratio of 1 to 2, 1 to 2, 1 to 3, which also gives us 1 to 12. So there's a couple of different ways that we can tackle that. All right? Here is like shapes, just like we saw, but it doesn't actually have the picture for it. It has a word problem for it. So it says, Jake wants to build a scale model of his house. The house is 48 feet long and 32 feet wide, and is 30 feet tall at the highest point. He wants to build a model 8 inches long. How wide? So the very first thing that we want to do is we want to mark what do they want and go find that other information back in there. So if they want wide, I'm going to go find wide and underline it, okay? If they give me 8 inches long, I'm going to go find long. So now I have my comparisons. So I can have 8 inches is to 48 feet as, I don't know how many inches, is to 32 feet. Okay? So as long as we set up our comparisons the same, did we even need the 30 feet tall? No, we don't. So one of the big mistakes that I see a lot on the test is not putting your pencil on your paper. Now, unless you're taking the December test where it's on the computer, which I personally don't recommend, you have your paper. They give you the whole side of the paper. Always be